In the popular book Harry Potter and the Order of the Phoenix, one of the portraits is observed saying, "You know, Minister, I disagree with Dumbledore on many counts, but you cannot deny he's got style." Okay, Harry Potter geekdom aside, style is very important when communicating what may be considered the dry results of a research study. That's what this video will focus on, communicating study results with style. Oh, and accuracy too. In particular, we will cover using tables and graphs to aid in understanding, word choice, and a brief discussion of methods for ensuring accuracy. I need to offer a caveat though. This information, advice, and insight is provided based on my experience as a professional researcher, and believe me, I've written lots of research reports. So if you're not one of my students, listen to your instructors. You've likely heard the cliche that a picture paints 1,000 words. Okay, maybe not 1,000, but a well-designed table or graph can often get your point across faster than a paragraph of text. Let me use an example. Say you have a series of questions worded as follows. How would you compare yourself to the average person in the following areas? As much worse, worse, average, better, or much better? Then you have a series of 15 variables from driving to study ethics. You run frequency tables for each variable. You could show and discuss each item separately, writing something like, on the topic of driving, 26% classified themselves as much better than average drivers, with 35% saying they were better and 33% reporting they were average. Just 4% acknowledged that they were worse than average drivers, and only 2% admitted their driving skills were much worse than average. Multiply that by 15 items, and you'll likely have your reader snoozing in no time. Given that this is a scale question, you might be better off running and reporting means, which reduces those 5 pages of data to a single page that you could put in a single table. Now you could report that on a scale of 1 to 5, with 5 meaning they thought they were much better than average, driving was assessed a 3.80, healthy eating at 3.19, and so on. And if you wanted to make it pretty, you could. But that's not as helpful as if you could sort or rank order from high to low. But even better would be to show it in graph form. Let's say we wanted to focus on the single driving variable in that first question. How much quicker could we get the point across with a pie chart? Okay, one more graph and I'll move on. I wonder if there is a difference in a person's assessment of their driving skills based on their sex. And for our example, we'll assume only 2 levels in that independent variable, male and female. So we run a t-test on that and find the following. Wow, look at the differences in the means. Males were more likely to assess their driving skills higher than females, a mean of 3.99 for males as compared to 3.64 for females. Let's set aside the issue of whether this finding is significant or not. For this video, we're just looking at how the use of visuals impacts understanding. So let's do a quick graph. And now you can visually see if there's a difference in the answers based on sex. Oh, and these graphs were made in Excel. SPSS will do graphs for you, but they aren't very pretty. Before we move on to the words you use when writing your report, let me focus a bit more on what you might show in the graphs. First, you should understand the difference between counts and frequency percentages, as SPS calculates and displays both. The counts, or N's, are the number of respondents who gave a particular response. In this example, 3 people said much worse, 6 said worse, 55 said average, etc. In all, 165 people answered the question. 1 refused. That's the missing system response. But those 3 people who said much worse represent about 2% of the entire sample, in this case, of 166 people, 1.8% to be exact. And notice that we tend to round to the nearest whole number when talking about percentages, because 1.8% implies a certainty that, because we are using a sample, we really don't want to communicate. Those 58 people who said better represent about 35% of the sample. If you use SPSS's graphs, it graphs based on counts. As you can see, the better category graphs at slightly below 60, which equates to the 58 people, not the 35%. So using counts is misleading. You want to use percentages. And by now you should know the difference between the percent and the valid percent numbers. This table doesn't do a good job showing it, but the percent is of everyone in the survey, including that 1 person who declined to answer this question, and anyone we may not have asked this question of. The valid percent is based just on the answers of who responded to the question. For graphs displaying means, make sure you establish the bounds on the axis, the minimum and maximum number you want showing on the axis. For this question, as the scale points range from 1, much worse, to 5, much better, you want to make sure the lower bound is 1, not 0, which is the default for Excel. Otherwise, your graph is misleading. Also notice that, for means, we tend to report to the second decimal place, 3.64 and 3.99, not 3.6 and 4. And I already noted that, for frequency percentages, we tend to round to the nearest whole number, 26% instead of 25.9%. Let's do a quick review so I can see if I forgot anything. Choose the best statistical test to use to show the data. Check. Use frequency percentages rather than counts. Got that. Report means to the second decimal point and percentages rounded to whole numbers. Yep. Pie charts do well for individual question results, while bar or column charts are good to show comparisons of similar items. Check, check. For bar and column charts, sort where possible and consider minimum and maximum values. Got that. One last one. If you are showing a series of yes/no answers, it's significantly less confusing if you show just the yeses, or the no's if that's what you want to draw attention to. Let's turn next to some writing conventions. When writing the report, use an impersonal style, writing "the study focused on" rather than "we decided" or "I thought." Use your thesaurus so you aren't constantly writing "respondents said." Try a variety of reporting verbs such as claimed, agreed, stated, complained, complimented, suggests, reported. You'll notice that I mixed up past and present tense in that example. The tense you use will depend on what you are writing. When reporting survey results, you are reporting what respondents said in the past, when they did the survey, so you would use past tense. Respondents expressed concern with. However, when you are generalizing to the population, use present tense. It appears that, or results suggest that. Try to vary how you report the statistics. 25% could be worded as 1 in 4 or a quarter of respondents. 55% could be over half, etc. One final suggestion. Although it's changing as many people are misusing this word to the point that it has become commonplace, the word data is plural. Datum is the singular word. So instead of writing or saying the data was analyzed, you should say data were analyzed. Now to the last section, which briefly focuses on accuracy. It's brief because there's not much to say here except please double and triple check your work. When we write, we can often figure out that there's a typo because the words don't seem to fit. But we don't notice, for example, if our numbers are off or even add up to more than 100% because of a typo. And if you're like me, you start analyzing the data and writing the report and preparing the graphs before all the field work is completed and we have clean data, planning to go back and update all of the statistics and conclusions later, and then forget or do an incomplete job. When I first made this graph, it was before all the data came back and I was prepping it. The draft numbers were different than the final numbers, which I corrected, but the percentage difference never got corrected. That was pretty embarrassing. So check this way. Print out a hard copy of your statistical and written reports and the tables or graphs you are referring to. Compare the data in the graph or summary table to the statistical table. Then compare your narrative to the graph and the statistical tables. Cross things off as you go. Or better yet, ask someone else to help you do it, one of you reading off the numbers from the tables, while the other checks the narrative and associated tables or graphs. You should now have a better idea of how to communicate your results to others accurately and with some style, using tables and graphs to aid in understanding, the appropriate word choice, and methods to improve accuracy. Now, I'm going to disappear here, but likely without the certain style of Professor Dumbledore. Poof!